Yeah, hello everyone. So in this class we are going to explain about subtraction involves one's complement and two's complement. So here we are having two cases. One is subtraction of small number from larger number, and case 2 is subtraction of larger number from smaller number. So how to subtract the two numbers by using one's complement. So already we know that one's complement means the inversion of the binary numbers. Zeros are converted as ones and ones are converted as zeros. So we'll see the case 1 now. So case 1 is subtraction of smaller number from a larger number. So it is given here, a example is also given. So in this, so how to subtract a smaller number from a larger number. So first we have to calculate the ones complement of the smaller number and add this ones complement of smaller number to the larger number. So if addition, in the addition means we are getting the sum. If carry comes in the MSB of the addition, so remove that carry and add it to the result again. So it is given the binary subtraction. In this example we will see that. So here 11010 is given, and one more number 10100 it is given. So in this case we are adding using ones complement for negative numbers. So 11010. So here subtraction means we have to add that numbers. We have to use the ones complement and add those numbers here. That is the binary. What is the difference between the binary subtraction and this ones complement subtraction? So we are adding this 11010, and here the smaller number is 10100. So we have to take the ones complement of this number, that is 01011. So we are adding these two numbers, then we are getting the sum like this, and in this sum we are getting that carry. In the MSB bit we are also getting that carry is added here, like this. So here we are getting at last 00110 for this addition. That means in the case of subtraction of smaller number from larger number by using the ones complement. So whereas in the case 2, subtraction of larger number from the smaller number. So how to? So here subtraction of the 2's complement number we are taking here. So subtraction of larger number from the smaller number. So first find out the ones complement of the larger number, add this ones complement to the smaller number. So now the result is in the negative form and in ones complement form. So to get the difference we have to again calculate the ones complement of the result, and we have to put the negative sign because we are subtracting the larger number here from the smaller number. So we have to use negative sign in the result of the addition. So here one of the example is given. The larger number it is given 111001, and the smaller number is 101011. So we have to first get the ones complement of the larger number, that is 000110, and add these numbers. So the two numbers are added here, so the result will get here. And so at last step what is that we are having, the result is in negative form, that means ones complement form. So to get that exact result, actual result, we have to ones complement that result, the addition. That means here this is the ones complement of that result, and already we know that it is a larger number we are subtracting from the smaller number. So we have to put the negative sign also here. So minus 00110 is the answer for this subtraction. So next, subtraction also involves 2's complement. So here also in the case of the ones complement, how we were subtracted the two numbers by in the case 1 and case 2, that means subtraction of smaller number from larger number, and in the case 2 subtraction of the larger number from smaller number. Here also we are having two cases, case 1 and case 2, in the case of the 2's complement method. So first one is subtraction of the smaller number from larger number, and second one is the subtraction of larger number from smaller number. So here we are using the 2's complement method. So in this case 1, subtraction of smaller number from a larger number. So it is given example. So the first we have to determine the 2's complement of the smaller number and add this add this 2's complement to the larger number, and if any carry occurs we have to discard that carry, eliminate that carry, remove that carry. So here one of the example it is given, the representation of 3. Okay, so 0 0 1 1 1, complement of 3 is 1 1 0 0. So 1's complement, okay, 2's complement of 3 is 1's complement plus 1, that means here 1 1 0 1 is 2's complement. So we are subtracting here this one, okay, 2 minus 3 here, okay, 0 0 1 0, so it is true, and minus 3, that is what is that, the 2's complement of minus 3, that is 1 1 0 1, so we are adding here this one, so we are getting what is that at last 1 1 1 1, this is the result we are getting. 2 minus 3, that is minus 1 is the result for this subtraction. Next, case 2. In the case of the 2's complement also we are subtracting the larger number with smaller number. So in this case first we have to find the 2's complement of the larger number, add the 2's complement of the larger number to the smaller number, then the result is in 2's complement form. So to get the difference we have to again take the 2's complement of that result and keep the negative sign here, because we are subtracting the larger number from smaller number. So we have to remember this, if you are subtracting any larger number from the smaller number means at last you have to put the minus sign here in the result. So it is the example also given here. So we are 2's complement of the 3 we are getting, and 2 plus of minus 3 it is coming, and at last what is that, minus 0 0 0 1, so it is the result we are getting here. Next, so binary arithmetic. So arithmetic means already we know that by using addition, subtraction, multiplication and division we can also perform by using the binary numbers also. So that means we can perform binary addition, binary subtraction, binary multiplication and binary division also can be performed. So how to do it? So first one, binary addition it is given. So first write the binary numbers into columns here. So perform the addition, carry the 1 to the next column on the left and add all the numbers, check your answer in the denominator. So here 7 plus 2 it is given. So we know that 7, the binary number for 7 is 0 triple 1 and for 2 is 0 0 1 0. So how to do it? By using 8421 code. So 8421 code we can use. For 7 it is having 4 plus 6 plus, what is a 4 plus 2 plus 1, that means 7. So here we'll put 0 here like this. And whereas 2 means, so in the place of 2 we are getting 1, so remaining are 0 0. 0 0 1 0 is the binary number for the 2 here. So 7 plus 2, so we can add directly. So here 1 plus 0 is 1, 1 plus 1 means 10 here. Okay, so we have to use this one, this table. So 0 plus 0 0 and sum. Okay, we will get in the addition we will get two types of results, one is called as sum and one more is carry. So 0 plus 0 is 0, sum is 0 and carry is 0. 0 plus 1 means sum is 1 and carry is 0, and 1 plus 0 means sum is 1 and carry is 0. In the case of the 1 plus 1 you have to remember it is, what is that, 1 plus 1 it is equals to 10 actually. So in this 10 what is that, this is 0 is going to sum and this 1 is going to carry. This is the important thing in the binary addition. So 1 plus 1 10 means 0 is in the sum, 1 is going in the carry here. So here also again 1 plus 1 it is adding, so here also we are getting 10 and one more carry is getting here. So here at last 1 plus 0 plus 1, that means 1. So when we check it, 8421 code with this one, so 1 0 0 1 means, so we have to add this one, 8 plus 1, so then we are getting 9 here. So this is the exact result so far in the case of the binary addition. Next we will see the binary subtraction here. So in this case start the subtracting bit in the lower row from bit in the upper row in a unit column. So if bit in upper row is less than the bit in lower row, so borrow 1 from the upper row of the adjacent left column. So write the difference in the result of the column, then repeat the above steps. Here we have to use this formula here. 0 minus 0, that means 0. 1 minus 1 is 0. 1 minus 0 is 1. But so in this case of 0 minus 1, when we are having 0 minus 1 means, so here we are getting 1 is going to borrow and one more is also going to difference. 2 will come here. In the case of the addition, we will get sum and carry, but here in the case of subtraction we are getting difference and borrow. So when 0 minus 1 in the case only, so we will get difference 1 and borrow is also 1 here. So 1 minus 0 is 1 here, already it is given, see here like this. 1 minus 0 is 1 and 1 minus 1 is here 0. So 1 minus 0, 1, 1 minus 1, 0 here, 0 comes here like this. Only in the case of the 0 minus 1 only you have to remember, that is the important thing. Next, binary multiplication. So how to multiply the binary numbers. So what are the rules here? So 0 into 0, 0, 0 into 1 is 0, 1 into 0 is 0, only one thing, 1 into 1 is 1 here. So binary multiplication follows the same steps as denary multiplication, and we'll use here long multiplication. So write the two numbers one above the other, then multiply each digit on one number with each digit on the other. So write them as separate numbers, shifting up a significant digit every time. Finally add the numbers together. Okay, so this is how we are doing here. 1100 into 1111. So we have to multiply this each number. So first we are taking the one number and we are multiplying with each number. Okay, so 1 into 0, 0, 1 into 0, 0, and 1 into 1, 1, and at last 1 into 1, 1, like this. So we are shifting this to one bit to the left and we are again multiplying with the next number 1. Like that we are to multiply with all the numbers and we will get that result like this. At last we are adding all the numbers here like this. Okay. Next, how to divide the two binary numbers, that is given here. So here in this case the binary division can be achieved in a similar fashion to dividing decimal values. So divide the divisor with the so here the binary division here we are getting. So in this case binary division can be achieved by using the same values like this, same fashion how to divide with the decimal values. So divide the divisor from the dividend, use the example like subtraction. So subtraction rules, 0 minus 0, first you have to take that number here. So for example the divisor is given, one more is dividend is given. So there is 100,110 is given, so it is a divisor 1011. So we are getting, for every division we are getting that quotient and one number is remainder. So 1011, so when we multiply this one with 1, so we are getting 1011 here like this. So we have to subtract each number from the first number and we will get that subtraction result like this, 0101. Then we are, what is that, we are getting that 0000 because it is not divided by 1011. So we are putting 0 here, then we are putting all the zeros here, then we are moving to the next number which is taken here, 1011. So that is 1011 is multiplied with 1. Okay, so then 1011 we are getting, at last we are getting that 0 is the remainder here. So 1010 is the quotient for this division. Next, so how to use the binary codes. So electronic digital systems use the signals that have two distinct values and circuit elements that have two stable states. So every digital systems are having the two signals. Okay, so that means the binary numbers zeros and ones are using, and every circuit elements also having two stable states. That means 0 means off and 1 means on here. So there is a direct analogy among binary signals, the binary circuit elements and binary digits. So a binary number of n digits, for example, may be represented by n binary circuit elements, each having the output signal values equivalent to 1 or 0. So digital system represent and manipulate not only binary numbers but also many other discrete elements of information. So any discrete element of information distinct among a group of quantities that can be represented by a binary code. So we are representing these binary numbers with some of the codes. Okay, they are called as binary codes here. So red is one distinct color of the spectrum, like that. The letter A is one of the distinct letter of the alphabet. So a bit by definition that is called as binary digit. So when used in conjunction with a binary code, it is better to think of it as denoting a binary quantity that is equal to 0 or 1. So to represent a group of uh, two n distinct elements in binary code that requires a minimum of n bits. So this is because it is possible to arrange n bits in 2n distinct ways. Okay, so for example, a group of 4 distinct quantities can be represented by a 2-bit code with each quantity assigned one of the following bits. Okay, so when we are using 0 and 1, these are the two binary numbers 0 and 1. When we are using these two, we will get four combinations. So that means 0 0 0 1 1 0 and 1 1. These are the four combination of the binary digits will get here. Okay, these are the four combinations 0 0 0 1 1 0 and 1 1. Next, what are the binary codes we are having? Okay, these are the classification of the binary codes. So first one is called as weighted codes, second one is the unweighted codes, third one is the binary coded decimal, that is also called as BCD, and the fourth one is gray codes. So here, what are the difference comparison between the weighted and unweighted codes here? So the weighted code is so in the weighted code, each digit position has a weight or value. So every digit is having a weight, that means a value is present. The sum of all the digits multiplied by a weight gives the total amount that is being represented. So we can express any decimal number in tens form, hundreds, thousands, and so on like that. So decimal number will write like 4327. How we will write this one? So in the form of the ones and tens, hundreds, and thousands, we will write like this. So how to, in the power of 10, how we can write this 4327 like this? 4 into 10 power 3 plus 3 into 10 power 2, like that we will write here. Okay. So BCD or 8421 is a type of weighted code where each digit position is being assigned by a specific weight here. Next, non-weighted codes. In the non-weighted codes or unweighted codes, there is no positional weight is present. You have to remember this one. So in the weighted code, we are having each digit position is present, which has a weight present. So in the non-weighted, unweighted code, there is no positional weight is present. Each position within the binary number is not assigned a prefixed value. So no specific weights are assigned to bit position in non-weighted codes here. So here having that unweighted codes or non-weighted codes like the gray code and XS3 code are the unweighted codes. So one of the binary code is given binary coded decimal, that is also called as 8421 code. It is important code. So simplest binary code for the decimal digit here it is only encodes 10 digits from 0 to 9. So BCD is a weighted code here. The weights are 8421. Same weights as a binary number. So there is a 6 invalid codes here in this, like these are the 6 invalid codes. And when we will have to write the BCD for 1 3, so 8421 case we have to use separately. So 1 means 0001 and 3 means 2 plus 1. So in the case of the place of 2 and 1 we are writing 1, remaining are 0. So like this 0011 is the so code for the so here 0011 is the binary code for 3 like this. So we'll use this binary code like this. Okay, so this is the BCD codes we are having. 8421 code is there, 4221 code is there, 5421 code is there. Okay, these are the BCD codes, binary coded decimal it is. So 568, how we are writing here? 5 means 0101, 6 means 0110, 8 means 1000. We are writing like this. Next, what is meant by the XS3 code? So the XS3 code is an important BCD code. So it is a 4-bit code and it is used with BCD numbers here. So to convert any decimal number into the XS3 form, add 3 to the each decimal digit and then convert into the BCD number. So as the weights are not assigned, so it is a kind of information. Okay? So it is a, what is it? Unweighted code. It is one type of the non-weighted or unweighted codes. So this is BCD code, it is the XS3 code which is given. So for 0 we are adding 3. So we are getting 0 plus 3, that is 3. So for that the equivalent XS3 code for 0 is 0011. Same like that we are adding for every code. For 9 we are getting, so 9 plus 3, that is equals to 12. So the XS3 code for 9 is 1100 like this. For every code we are adding 3 plus 3, then we are getting the XS3 code for that equivalent to BCD code here. Next, gray code. So gray code is also a system, so that is also represented in binary format, so in which every successive pair of number differs in only one bit. So it is used in applications in which normal sequence of binary numbers generated by the hardware may produce an error or ambiguity during the transition from one number to the next number. So how to convert a gray code into a binary code, so that is given here. So for example, the gray code G3, G2, G1, G0 is given. So we have to get in the binary format like V3, V2, B1, B0. So what we are doing here? So first we have to write that MSB of the gray code same like that, and we have to XOR, okay, produce an XOR for this one, okay. So B3 XOR G2, then we are getting this one B2, and the resultant B2 is again going to XOR with G1, then we are getting B1 here. Next B1 is again going to XOR with G0, then we are getting B0 like this. So this is the process of how to converting a gray code into the binary code. So these are the important table it is given. So how we are representing all the codes here: decimal code, binary code, gray code, BCD, and XS3. How it is performed. So already we know that decimal numbers are from 0 to 9 here. So we can represent the binary numbers like this. Okay, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 like this. And the gray code is here like this. So by using the XOR, and BCD also same as the binary coded decimal, that means we are using here 8421 code, and the XS3 means so for every number, okay, for every number of decimal we are adding 3 and we are getting that binary number, okay. XS3 means addition of 3, okay, remember addition of 3 means we are getting that XS3 code. Add 3 to every decimal digit, then convert into the binary number. So how we are converting? So already we will see one of the example. Gray code is how to convert a gray code into binary. So 1010 it is given. So this 1010 is, what is it? It is a gray code format it is given. So we have to what is that? Add first, what is that? Take that MSB like that only, and perform the XOR with this 0, then we are getting that 1. So in the case of the XOR gate, you have to remember, for 0 XOR 1 we are getting 1, 1 XOR 0 we are getting 1. So remaining cases, for 0 0 it is we are getting 0, for 0 what is that, for 1 1 also we are getting 0. That means when the inputs are different, the output is equals to high here in this case. So like that, the gray code for what is the binary code for that given gray code is 1100. So 1010 we are getting the binary code 1100 like this. Same here, how to perform that binary code into the gray code. So it is given 11101, it is given binary code, so we have to perform that. Okay, so here 1 is written like that only. So the next number of this, what is a gray binary number only, you have to multiply what is the XOR, do it perform that XOR with the next number. So then we are getting 1 1 means we are getting 0, 1 XOR 1, 1 XOR 1 is 0, next 1 XOR 0 is 1 here, next 0 XOR 1 is 1 here. So this is the format how to convert that binary code into the gray code and the gray code into binary code formats. So these are the some of the conversion examples, and it is the important table to remember the decimal numbers, binary numbers, breakcode numbers, BCD numbers, and XS3 numbers. So all these are the topics of the number systems what we were discussed, different topics discussed. So just I am changing the slides and just you can revise that topics. So what are the number systems? It's the graphical representation of the number systems, and this is the decimal number system, and how to denote that decimal point and decimal number, and what is meant by binary number system, and how we are denoting that binary numbers like this, and so how the bit positions are present in the binary numbers, and what is meant by octal number system. So how we are denoting the octal number, how the values of the positions, and what is meant by hexadecimal number. So we have to remember this is the hexadecimal number means this is the alphabetic and numeric number, alphanumeric number system. So we are having 0 to 9 are the numbers, and A to F are the alphabets here we are having. Next, so this is the how we are denoting the hexadecimal number. So next, binary number system. So how to convert the binary number into decimal number, and so how to convert that binary number into octal number, and how to convert that binary number into hexadecimal number, and what is decimal number system. So how to convert the decimal into binary conversion, and the conversion from decimal to octal, and how to convert a decimal number into hexadecimal number. Here it is given octal number system. So in this case, how to convert octal number into binary number. So how to convert octal number into decimal number. So how to convert octal into hexadecimal number. So we may see hexadecimal number also. So how to convert that hexadecimal into binary. Okay. So this is also given example. So next, how to convert the hexadecimal number into decimal number system. So how to convert the hexadecimal number into octal number system. So next, binary complements also we were discussed. So in this case we are having the 2's complements like 1's complement and 2's complement, and already we have discussed that subtraction of the two numbers when by using 1's complement, two cases, subtraction of smaller number from larger number, and the subtraction of larger number from smaller number. So in this case one, it is subtraction of smaller number from larger number, and subtraction of larger number from the smaller number here. The next, second 2's complement also we are having two cases, subtraction of smaller number from larger number, and the subtraction of larger number from smaller number. So like this is the case 1, and this is the case 2 here. So also already we have discussed that the binary arithmetic like addition, subtraction, multiplication, and division. So this is the binary addition, and it is the binary subtraction, and this is the binary multiplication, and this is binary division like this. So next we are also discussing that binary codes here like this, having like four types of codes: weighted codes, unweighted codes, binary coded decimal, and gray codes. So what is meant by weighted and what is meant by unweighted codes? It is given, comparisons is given here. So it is given 8421 code, and next one the XS3 code is also given, the gray code it is given here, and also the table for all these codes: decimal, binary, gray code, BCD, and XS3 it is given, and also conversion, how we are converting gray into binary, binary into gray code, and the next one. Okay, so these are all these conversions, and number systems, converting one number system to another number system, and so binary, what is arithmetic is discussed, and also ones and twos complement also discussed. Okay, so these are the total number systems.